Corporate finance practice problem using Onenote. Find bond market rate or yield. This is the second problem of a similar nature. Get ready. It's time to take your chance with corporate finance. Here we are in Onenote. If you have access to Onenote and would like to follow along, you're not required to, but if would like to, we're going to be on the icon on the left-hand side. We're down here in the practice problems and the 1025 calculate bond rate and change in rate Prob 2 tab. Also note that when using Onenote, you might want to look at the immersive reader. Many of our presentations up top will be mirrored down below in the text file area. Text files having transcripts that can be translated into multiple different languages and either listened to or read in those languages, thereby being a good complement to the practice problems up top. You can find them with the same name and number within them. Closing this back up, we're going to have our information up top, then we'll go through the calculation for them down below. Scenario will be, we have the bonds that are issued, we have the $1,000 par value, 25 life on the bond. Then we're calculating the price that is going to be on the bond, noting that when we first calculate the price on the bond, when issuing the bond, if we are the issuer of the bond, then we're trying to get a price that is equivalent to the market rate and thereby issue the bond at the 1,000 or face amount of the bond. If that does not happen, if we mess up on the price, or if time passes, it's likely that the price on the bond will not match the price in the market price the market wants, and therefore you will have a discount or a premium. So let's think about the situation down here, the things you might want to consider, whether or not you are making the bond price at the beginning when first making the bonds to be distributed, or when you're thinking about the price that you think is fair with regards to a market price, noting that this isn't like an exact science because bonds are different, but you can kind of lump bonds together that are of a similar nature and have a similar possible rating and things like that, and try to think about what the market wants within that range. So you could consider things like the real rate of return, the inflation premium, and the risk premium in order to determine what you believe would be an appropriate rate on the bond to either issue or purchase a bond at. Now, in this problem, we're going to imagine that we actually issue it at the market rate, that being the 16%. We're going to actually calculate the value, which will be the 1,000, using our present value calculations, which seems obvious, kind of is obvious, but then when you actually do the calculations, is less obvious. So we'll do that first, and then we'll imagine that time has passed. So the movie screen flashes forward, blank screen, scrolling in, and it says 10 years have now passed. The bond has served as well. But now the risk premium is 3% as opposed to 7%. And so that what's going to be the price of the bond at this time. And so what we'll do then is calculate the price of the bond at that point in time, the risk premium now being less than it was before, which is going to bring down the total rate on the market rate now being less than the rate that was on the bond. And that's going to result in a situation that if we were trying to sell the bond and the bond had a rate higher than the market rate, the seller would have an advantage in essence, right? Because they could say, you can't find a bond around here that pays a rate that is as high as we have our bond for of a similar nature. Therefore, we're not going to sell it to you at the $1,000 face or par value. We're going to sell it at a premium. So at that point, we expect then the rate to go up. What will it go up by? We'll have to do the calculation in order to do that. Let's first calculate with this 16%, and we're going to say that that is actually the rate that was issued at when the bond is originally issued, and it's the market rate, which means that we expect the result to be the $1,000, but it's a little bit less intuitive when we actually do the present value calculations that will indeed be the case. So we'll do our same calculations with the present value of an annuity, present value of 1. First, the annuity portion is going to be P. P is going to be the 1,000 times the 16%, 16% in this case being the amount that would be on the bond, the rate on the bond, times 1 minus 1 plus R, R being the 16%, but this time representing the market rate, to the negative N, N being the number of periods, in this case 25, divided by R, also the rate, which in this case 16% market rate. Let's plug that into our table down below. We're going to pick up the 1,000 times the 16% would be the annuity payments that would be paid, in this case, in an annual basis, the 160. Then we have the numerator 1 minus, we're going to pull in the other to the inside, 1 plus r to the negative n, 1 r 16%, that indicating or representing the market rate now. Adding those together gives us the 116% or 1.16 to the power of the number of periods, which in this case is 25, in this case years, so we're paying yearly, and it's the negative 25, so 116% to the negative 25 gives us that 0.0244653. We're going to do that calculation one time with our calculator, noting that we need like a scientific calculator or something that can take us to the power of negative 25. So I'm going to pull up the Windows calculator, hamburger, scientific calculator down below, and we want to take the 1 plus the 0.16, which is 1.16 or 116% to the xy, in other words, power of caret up top, the number of periods, 25, and then I'm going to make it negative with this little thing down here, negative 25. So 1.16 caret to the power of negative 25 gives us that 0.0244653. Gonna change this back then to a normal calculator, because if I'm not being scientific-y, I like to be in the normal calculator. And then if we take the 1 minus that amount, we'll get the num number, the num. 1 minus the 0.0244653, there's the num number, the num, 0.9755347. Divided by the denom, that's going to be this number, r, which is 16%, that's the market rate. So divided by the denom, 0.16, r, 16%, in other words, gives us the 6.0709197. And then take that and multiply it times the 160, and we get the 975.53 about. So that's going to be the amount of the annuity. We're going to add then the present value of the 1,000, present value of 1. But before we do, we're going to calculate this a couple different ways. We'll do the annuity and then the easy way, which will be the Excel formulas. Note that you can break down a present value of an annuity into multiple present value of 1 calculations. That's what we'll do here. We'll say, let's break each payment down back to the current time one by one at a time. First one, 160. That 160 is the 1,000 times the 16%, present valuing it back 1 period to the current period. That'd be 138. Note that this present value, we're not going to do the calculation here. This is just kind of the theory portion. We do this in Excel. If you want to see all the Excel lingo, you can go there and figure it out. We will do a present value calculation shortly for the $1,000. Then period 2, we've got the 160, pulling it back 2 periods gives us the 119. That plus the 138 gives us the 257. Period 3, we got the 160 again because it's an annuity and all the payments are like the same. So if we bring that back, that's going to be 103. Adding the 103 to the 257 gives us the 359, and so on with the so forth until we get down to 25 periods where we're at the 976 again, that being the value of the annuity portion. Note that we can do this same process for the value of the bond, which we would then get the face amount or par value of the bond, principal in other words, with 25-year period. Taking this back 25 years, that would be worth $24. 24 plus the 976 is just what we expected it to be, the $1,000, because we had the same market rate and the same rate on the bond. However, let's get to this 24 one more time, actually calculating the present value instead of just doing it magically up here. So we can calculate the 975. Let's do this one more time, and then we'll do the 1,000. The 976 or 975 point something. We can also do with Excel. So here it is with Excel formula. Present value, brackets, rate. That's going to be the market rate, which is 16%, comma. Number of periods, 25 of them, in this case years, comma. The payment is the 1,000 times the 25, or 160. That then gives us the magic way, in the magic way format, 975.53 again. Then let's do the same thing with tables. We can do the same thing with tables. That 160 annuity payment, which was the 1,000 times the 16%. We can then take the tables, which are 16% and 25 periods, and look on the proper table, this being the annuity table. 16%, we're looking 25 periods. 25, 6.0971. So 160 times 6.0971 gives us the 975.54 again. That's slightly different than the 975.53 due to the table's rounding. Now, let's do the second half, getting to this 1,000, bringing it back 25 periods with the present value of 1 calculation. Formula looking like this: present value equals the future value times, or I like to say over, 1 plus r to the n, future value 1,000, 1 plus rate, market rate, this case 16%, to the power of n, that the number of periods, 25 years in our case. Plugging that in a table type format, we have the 1,000 outer column. We're bringing the 1 plus r to the n inside. 1 r, 16%. We're considering that the market rate here. 1 plus 16%, 116%, or 1.16. Taking that to the power of 25. 116% to the power of 25 is 40.874244, and so on. And then if we take the num, 1,000, divided by the denom, 40.874244, we get 24.47. And if we take that, that's the present value of that 1,000, which is the present value of the principal, in essence, adding it to that 975.53 that we got, which was the present value of the annuity that we did like 100 different ways up top. Then we get back to the 1,000 like we knew we would, but it's not quite as intuitive as you would think when you actually do the calculations. That 1,000 matching the par value, it matches the par value because, not because we just issued it per se, although they're kind of related. The fact that we just issued it means that the rate on the bond is equivalent to the market rate, but it's because the rate on the bond is equivalent to the market rate, which is more likely to be the case when it was just issued. But that's why we came out to the same price as the par value of the bond. Now let's say it differs here. Let's say we switch things up because now time has passed. Actually, before we do that, I'm jumping ahead of myself. Let's calculate this same 2447 a couple different other ways here. We'll do it the Excel way. Present value times the rate, which is 16%, comma, number of periods, 25, comma, because it's not an annuity, but present value of 1. Future value, 1,000. That gets us to the 24.47 again, the magic way. We can also do it with the tables. 1,000, looking at the table, picking up the proper table, this time present value of 1, not an annuity. 16%, 25 periods. 16%, looking 25 in this column. 25.0245. So there's 1,000 times 0.0245 is the 24.5. That close to, not exact to, the 24.47 due to the table's rounding to 4 digits. Now we can move on to the next thing, which is now time has passed, 10 years have passed, and now the rate is different. So we're going to come up with a price that is different. The price will not be different simply because 10 years have passed. The price will be different because in that different time period, the expected rate in the market is different than the rate on the bond, which is, again, more likely to happen after time has passed. But the fact that time has passed isn't the reason. It's because the rates are different that we're going to come up to a different rate. So in any case, this risk premium is now 3%. So if we recalculate this, we got 5% plus 4%. Hold on a second. 5 plus 4 plus now 3 instead of the 7. We're now looking 21%. That's not right. Hold on. 5 plus 4 plus 3 is 12%. So now we're looking 12%. So it has gone down. So this 16% is still going to be the rate that was on the bond, even though time has passed. But the market is now looking at 12% rate. So if we were to sell the bond now, if we were the seller, we would kind of be at an advantage. We'd be like, hey, you can't find a bond out there that's like our bond, which will pay you 16%. You can basically only get bonds of our quality for 12%, so we could sell it at a premium. You would think that we would be selling it at a premium. So that's what we expect to happen. What exactly will the price be? Well, we need to do the calculation if we want to be exact about things, if you want like an exact answer. So now we're going to then go to calculating this again. We'll use the annuity and then the present value of 1 with our new circumstance. So P is now going to be the 1,000 times the 16, that hasn't changed, times 1 minus 1 plus R. R now has changed because that's the market rate, which has 12%, to the negative N, which is now changing because it was 25, but 10 years have passed. So 25 minus 10 is going to be 15, divided by R, also the new 12%, the new percentage. So then if we plug that into our table, we got the 160, no change there. That's the 1,000 times the 16%, the bond rate amount. Then the numerator, 1, and then 1 plus R to the negative n, 1 plus R, rate 12%, just like we said up top, gives us the 112%. And then we take that to the negative n, because that's the number of periods. That was 25, but 10 years have passed. And 25 minus 10 means there's 15 periods remaining. So 112% to the power of negative 15 gives us 0.1826926. And then if I take the 1 minus the 0.182692626, I get 0.81730374. That's the num, or numerator, divided by the denom, or denominator, which is 12%. The 0.81730374 divided by 12%, or 0.12, gives us 6.810864449. That times the 160 gives us our answer, 1,089.74. That's going to be the present value of the annuity portion. We still need the $1,000 present value, bringing it back. But before we get there, we're going to recalculate this one a couple different ways. We can break the annuity down into multiple payments, 15 payments of present value of ones. So we could say payment 1, 160. That's the 1,000 times the 16%, just like it was before. But the present value calculation, different now because it's taken into consideration the market rate 12% rather than the 16%, now giving us the 143. Payment 2, 160, that's the same because it's an annuity. And we present value that gives us the 128. We're not doing the present value calculations, by the way, here. That would be done in Excel. If you want to see this in Excel and go through those actual calculations and do it that way, you can do so. I highly recommend doing so. It's good times. So the 128 plus the 143 gives us the 270, and so on. If we did that again, the 160, bringing it back 3 periods, we got the 114. 114 plus the 270 gives us the 384, and so on and so forth, till 15 payments, because we only have 15 this time, because time had passed. That ends off at the 1,090. If we were then to present value the 1,000 in a similar fashion, we get a higher result due to the fact that that 1,000 is closer to being paid at this point in time. It's not 25 years out anymore. It's only 15 years out. It's worth 183. Adding that to the 1,090 gives us the 1,272, that being in essence the price of the bond, although no pennies are included here. That amount higher than the 1,000 par value, not because time has passed necessarily, not because there's 15 periods as opposed to 25, but because in the time period that we are in, the market rate happens to be less than the rate on the bond. The bonds, therefore, giving a return higher to the investor than the market rate, and so we can sell them at a premium. Let's calculate this 1,090 again down here the easy way, the Excel way. Present value is going to give us the rate. That's going to be the 12%, comma. Number of periods is now 25 minus 10, otherwise known as 15, comma. And then the amount is going to be the 1,000 times the 16, or the 160. That will give us magically that 1,089.74. We can also do it with the tables. We get the 160, looking at the proper table. This time 12 and 15 are what we're looking for. 12%, 15 on the periods. So 12% here, we're looking periods 15. We get the 6.8109. 6.8109 times the 160 gives us 1,089.74. Then we could do the present value of that 1,000, bringing it back using the present value of 1 formula. Present value equals the future value. I could say over 1 plus R, now 12% to the n, 25 minus 10, or 15. Putting that into our table, 1,000. Then we got the 1, and then the rate, 12%. 1 and 12 gives us 112%, or 1.12 to the power of 15 will give us the 5.4735685. The num over the denom gives us the 182.70. So that's going to be the value of the 1,000 present valued. Once again, adding that to what we got with the annuity, 1,089.74 gives us that 1,272.43, that the value or price of the bond at the 12% rate, that amount greater than the par value, the 1,000, due to the fact that the rate on the bond is now less than the rate, the rate on the bond is this one, is higher than the market rate. Okay, so let's get to this number again, this 182. Let's do it the easy way now, Excel way. That's going to be the present value is the rate, which is 12%, comma, number of periods. Now, the 25 minus 10, or would be 15, comma, comma, because we're not talking annuity, but present value of 1, future value 1,000. That then giving us 182.70 again. We can do that one more time. We can do that with the tables. So tables, making sure we get the proper table, present value of 1, and I don't have the tables aren't here. We're going to end off not having the tables. That's okay. We won't do the tables on the last one. I'm blaming my editors here. The table's not there. But in any case, we would be looking on the table for a table of 1 rather than an annuity. We're looking 12%, and the periods would then be the 25 minus 10 or 15. So 12 and 15. We would then find on the table, had we had one, 0.1827. See, I'll pretend it's down here. It's right down here. There it is on the table, 0.1827. If you can't see the table, it's not our fault. It's problems on your end. Your screen has a problem or something. Anyway, 1,000 times the 0.1827 gives us the 182.7 once again.